I think a lot of us are waiting for the same thing. That one model that's good enough to just do the work. Without paying frontier prices every month, that runs on a plane with no Wi-Fi where your code never leaves your laptop. So last week, Qwen dropped 3.8-27B, and I thought maybe this is the one. I didn't read anything. I just typed llama run and hit enter. It crashed my Mac, and then it did it again. Look, I'm not an ML researcher. I've got a MacBook with 24 gigs of RAM, same as a lot of you. So I spent the week working out what I'd got wrong. 4 things I'll show you. There's a number Apple doesn't print on the spec sheet, and it decides whether any of this works. The fix every forum gives you is backwards. It made my crashes worse, not better. One of my own tests broke my own grader. The model was right, I was wrong, and I'll show you where. And at the end, I hand it my telly and let it decide what my kids are allowed to watch. It's running now, 12.87 tokens a second. Here's everything I got wrong first. So this is what I'm working with: a MacBook Pro, M4 Pro, 24 gigs of unified memory. That's it. No external GPU, nothing clever. And the models Qwen3.8-27B, the GGUF build from Unsloth. They're the folks who repackage these things so they'll run on normal hardware, and that UD on the file name is their recipe. Now here's the thing I didn't know. A token is just a chunk of text, roughly a short word or a piece of a longer one. Everything the model reads and writes gets counted in those. I mention it now because pretty much everything else depends on it. So my Mac has 24 gigs, but the graphics chip doesn't get 24. It gets 17.76. It's a bit like a 24-seat bus. 6 of those seats are the driver, the door, and the engine. The brochure says 24. You get 18. And Apple doesn't really put that number anywhere. So I grabbed Q4KM because that's what everyone recommends. It needs about 19.5 gigs once it's actually running. That's 110% of what I've got. The screen froze, the machine rebooted, and it left this behind. And look at the compressor, 4%. So it's not that I ran out of memory. It's a bug in Apple's graphics driver. And look, it's not just me. Go searching and you'll find people on Macs with way more memory than mine hitting the same wall. Someone on a 64 gig MacBook saying memory is super tight. Someone whose Mac keeps rebooting during long runs. And this one, which is the exact thing I saw, your Mac is hitting a hard memory limit and the kernel is panicking instead of gracefully running out of memory. Even Unsloth's own source code has a comment about a user on a 32 gig M1 Max whose machine panicked twice on this exact model. So if this happened to you, you didn't do anything wrong. So then I did what the forums say: raise the wired limit. And honestly, it made things worse. Here's why, and it took me a while to get this. Normal memory is like a car in a car park. If you need the space, you tow it. Wired memory is bolted to the ground. The system's not allowed to move it. So when you raise that limit, you haven't made the car park bigger, you've just bolted down more cars. Now there's less room to shuffle, not more. I raised it and it panicked again. So why shrink the model at all? Well, at full size, this thing's about 51 gigs and I've got 17.76. It's not close. Shrinking it is kind of like swapping a 65,000 color paint set for a box of 16 crayons. You can still draw the picture, it's just a bit less subtle. And that's the whole game, really. Finding the fewest crayons you can get away with, that still fits. So these file names look like nonsense, and I thought so too, but they're actually pretty simple. Take UD-Q3K-XL. The UD is Unsloth's recipe. The Q just means it's been shrunk. The 3 is roughly 3 bits per weight. Full size is 16. The K is the family. Every little drawer of weights mixes its own 16 colors. And XL is the size tier. They go extra, extra small, small, medium, large, extra large. So bigger number and bigger tier means better and heavier. You want the biggest one that still fits. Now, if it says IQ instead of Q, that's the one bit people get wrong, me included. The I doesn't stand for importance matrix. It's an I quant. Instead of every drawer mixing its own colors, there's one shared palette, and the shades were picked after looking at all the drawings first, so you get a bit more quality per byte. The importance matrix is a completely separate thing, and it works on either kind. I had this wrong for ages. So there's a second thing eating your memory, and it's not the model. Every token the model reads, it writes a line in a notebook, so it never has to reread the conversation. That notebook's the KV cache, and the longer you talk, the thicker it gets. But your desk isn't getting any bigger. 16,000 tokens of context isn't free. Those two flags, CTK and CTV, shrink the notebook itself, and you get most of that space back. So this is why the download size lies to you. The file's 13.3 gigs, but it's a bit like airport baggage. They weigh the suitcase and the coat and the laptop bag. What actually has to fit is 17.3, and I've got 17.76. So here's every option, scored against what my Mac can actually hold. And the number that matters is the peak, not the file size. Q4KM, the one everybody recommends, 110%, it won't even load. iQ4XS runs, but it's at 97%, which is basically the edge of the cliff. Q3KEXL at 90 is the one I'd actually pick. So I got tired of doing that arithmetic by hand and made it a command. The package is called local fit, and the command it gives you is lumrun. Sorry, that's confusing, I know. Point it at any model and it'll score every version against your machine. And you can check a machine you don't own, which is handy if you're deciding what to buy. Here's a 16 gig Mac. Only the 2-bit version is safe, and honestly, at that point, I just run a smaller model. Now, most of you aren't on a Mac, so the tool takes a flag when you tell it how much GPU memory you've actually got, and it scores every quant against that instead of against my laptop. 12 gig card, 24 gig card, whatever. And if you are on a Mac, remember that number isn't the one on the box. Apple hands the graphics chip about 74% of your RAM, so a 16 gig Mac is really 11.8. 24 is 17.8, 36 is 26.6. That's the number to type in. But what if it just doesn't fit your machine? Because for a lot of you, it won't. And honestly, that's where I got stuck for a bit. I've got the tool telling me it won't fit, which is useful, but it's still a no. So I made it not be a no. Same command, one extra flag, and it goes and runs the thing somewhere else. Kaggle gives you a free GPU. It's a T4 or a P100, 16 gigs, and it's genuinely free. You just need an account. LocalFit picks the quant that fits that card instead of yours, pushes a notebook, starts the server, and opens a tunnel back to your laptop. You get a normal OpenAI style endpoint. Your agent doesn't know or care that the model is running in a data center somewhere. And if you need something bigger than a free card, RunPod rents you a real GPU by the minute. Same flag, different provider. I set a budget so it kills the pod when the time's up, because I have absolutely forgotten to shut one down before. My whole bill for this video was 23 cents. So if it fits, run it local. If it doesn't, you're not stuck. Quick thing about actually running this, because it matters. At 90% of budget, there's no room for anything else. So before every test, I'd quit Chrome, stop Allama so it wasn't holding a model in the background, and kill any leftover headless browsers. That got me from about 12 gigs in use down to 5.5. And I'd check it with vmstat before hitting enter every time. If you skip that step, you're the one who crashes, not the model. And I did try this with actual coding agents, not just curl. PyRust worked. That's the one I'd use. Regular Pi worked too, bit slower. OpenCode I couldn't get working. Its system prompt is huge, and the model kept losing the thread, so your mileage depends a lot on the harness. And honestly, I'd start with PRust. So does it actually work? I gave it a set of jobs it had never seen, and I didn't grade any of them myself. PyTest did, and Terraform, and a test runner, a Python class with 3 bugs I'd planted. 6 out of 6, and the fix was 3 lines, 1 per bug. A Terraform file with 2 errors. It fixed both, and it didn't just delete things to make the checker happy. Every resource is still there. Then I asked it to write an algorithm from scratch. 14 out of 14. And I didn't trust that, so I threw 20,000 random cases at it against my own reference. 20,000 agreements. And then, this is the bit I promised you. My reference was wrong, not the model, mine. It had merged 2 things it shouldn't have, and the model had it right the whole time. So then images, and this one only runs on the smaller version because the bit that lets it see costs another gig, and that tips it over. 31 facts out of 32, a French form, an Arabic flyer right to left, a receipt where it redid the maths itself, and a bar chart. And on Google's own test images, it read a Japanese sign, character perfect, so it works. It's slow though, 4 to 11 tokens a second, so you'll be waiting. So that's the benchmarks, but a score out of 10 doesn't really tell you whether the thing is useful. So I gave it an actual job. My telly's an Android box, which means the laptop can talk to it. And I told the model, right, you're in charge of what my kids are watching. It gets 3 tools. 1 tells it what's playing, 1 takes a screenshot of the actual screen, and 1 shuts the app down. And the rules are just a text file I wrote in plain English. Ages 6 and 9, cartoons are fine, horror isn't. That's the whole config. There's no code in it. So here's a real run. 2 checks, about 90 seconds apart. First one, the title says, Clips that made iShowSpeed famous. It takes the screenshot, actually looks at it, and says, that's a Fortnite lobby. Webcam in the corner, live chat down the side. Unvetted streamer content, not on the list, blocked. Then it checks again. This time the title says, Tom Holland laughing meme. And it goes, no, it isn't. What's actually on screen is some short form compilation called Busan Bistro. Blocked again. Twice the title was wrong. Twice it went and looked instead. Now I'm not going to pretend it's perfect. It stopped the app, and about 20 seconds later, the app just relaunched itself and carried on. So 1 block doesn't hold. It has to keep checking. But here's the catch. 1 check took 23 seconds. Another one took nearly 12 minutes. So you can't have it looking every 30 seconds. It's a patrol, not a guard. And honestly, for something running on a laptop with no API key, I'll take that. Right, that's the telly. But I wanted to know how good the seeing actually is, and for that I needed a clip I could legally put in a video. So, Big Buck Bunny. It's free to use, it's a cartoon, and nobody's going to claim it. 4 seconds of it, 8 frames, straight into the model on my laptop, And it did well. It got the forest, it got the burrow, it even got the camera slowly pushing in, which is the sort of thing you only notice if you're actually watching rather than glancing. And then it told me the animal was probably a gorilla. Hold that thought. Now, Qwen's own page says this does hour-long video, and it does, yes, on a proper GPU, with 260,000 tokens of context. I've got 16,000, but here's the bit I didn't expect. Llama.cpp can actually do video. The decoder's in there, it shells out to FMPEG. The server just refuses a video file type, so you label it as a PNG, and it goes through anyway. I gave it a full minute off my telly, 120 frames, 14,000 tokens, and it took 3.5 minutes to answer. It got every scene in order, and it read the French caption right. So about a minute of video on a laptop, not an hour, but I'd have told you it was impossible if I hadn't tried it. So how does it hold up against the cloud? Same 4 seconds of Big Buck Bunny, same question to all of them, and I nearly got this wrong twice. First, I'd left thinking on for Gemini and turned it off on mine. Then I found Gemini was only getting a quarter of the pixels because there's a resolution setting and the default is low. So I matched them up properly and then asked, what animal is in the burrow? Mine said a gorilla. Molmo said a mole. Gemini Pro said a bear. It's a rabbit. Only Gemini Flash got it. Everybody else looked at a dark shape in a hole and guessed a furry mammal, which is a perfectly sensible guess and wrong. They all got the camera move right, mind you. It's the identifying that's hard, not the watching. So, speed, 12.87 tokens a second. That's about reading pace, roughly. And I wondered if I'd set it up badly. Turns out no. This chip moves 273 gigabytes a second, and if you work backwards from that, you'd expect 12 to 15. So that's just the machine. There's no flag that fixes it. Oh, and the smaller version was actually slower, which surprised me. One last thing, and this caught me out. If you're using it with a coding agent, the speed you care about isn't this one. It's how long it takes to reread everything you already said. Llama.cp remembers 0.4 of a second. MLX starts over every time, 4.7 seconds, every single turn. So MLX benchmarks faster and it feels slower. So it runs. And I didn't buy anything to make that happen. I just stopped guessing and measured what the machine actually gives you. Everything's in the write-up and the tool's free. If this saved you a crash, subscribing genuinely helps. Next one's the head-to-head. This against Gemma 12B, same laptop, same tests, and I'll publish every number either way.